Okay guys, so in each case find the value of x, okay? So what we have here is 5x equals 2 root 5 over 3 root 5. What we can do here is bring the 3 root 5, bring the whole thing up beside the 2 root 5. So 5x equals 2 root 5 multiplied by 3 root 5. Now 2 root 5 multiplied by 3 root 5 will get you 30 when you put it into the calculator. Divided by 5, x equals 6. Everybody alright with that? Okay. What you have next in 5 part 2, guys? What's 5 part 2? 8 over root 3 divided by equals x. Now, you could do it this way. Like you could say 8 over root 3 divided by 2 over root 3. And that's great and all, but eventually you're going to have to understand how did I get 4 is the question, okay? How did I get that answer? So what I'd say is that anytime you divide by a fraction, what you do, you turn the second one upside down and multiply. What's root 3 divided by root 3? 1. 8 divided by 2? 4. So x equals 4. It's not too bad, is it? Okay. And now what about the third one? Root 11 over 3 plus root 11 over 3 equals x. Well, this is very easy. Is the denominator the same on both sides? Yeah? So x equals root 11 plus another root 11. X equals 2 root 11. That's it. Okay. Is just multiplying these out. I'll just do one of them, okay? I'll do the last one, yeah? Part 4. Alright, 2 root 3 multiplied by 2 root 3. Now, you should eventually get to the stage where you can do this in your head. 2 times 2. 3 times root 3 times root 3. 4 times 3. There you go, 12. No. How to explain this? Okay. The number 48, yeah? The number 48 is 6 multiplied by 8. Would you agree with that? 6 in turn is 2 multiplied by 3. And 8 can be written as 2 multiplied by 4. Yeah? You only multiply the 2 by one of them. You don't multiply the 2 by everything there. Otherwise you get a really, really big number. So in the same way, I chose to multiply the 2 off the other 2. And the root 3 off the root 3. So I only used them once. And then I used both answers against each other. As opposed to going root 2 by that one, root 2 by that one. That's not the way you multiply it out. I'd also ask you to refer back to, remember when you're multiplying 2x by 2x, you multiply the 2 by the 2 to get 4, and then you get x by x to get x squared. You don't actually do anything else. So that's what I'm trying to say. It's the same sort of multiplication. Yeah, 12 over here. Okay. Now, 2 root 3, is that a plus? 2 root 3 multiplied by 11, guys? Wait, is what? 22 root 3. The 2 gets multiplied by the 11, and you can't multiply it in. In the same way, 2x multiplied by 11 is 22x. That makes sense? Treat the root 3 like an x. And then minus 11 times 2 root 3. Minus 22 root 3. And finally, minus 11 by plus 11. Minus 121. What happens? 12 minus 121. Minus 109 equals k. That's it. Are we alright with that? Is there any need to do the other ones, or do one more? Okay. Which one? Part 3, okay. Same deal. What is minus 5 multiplied by minus 5? minus 5, plus 25. Minus 5 multiplied by root 7, minus 5 root 7. Okay, what's minus root 7 times 5? Minus 5. And finally, what's root 7 times root 7? Minus 7. Sorry? In the middle? That's a minus 7. What? Sorry, what was the question? I don't understand. No, because you're multiplying minus 5 gets multiplied by root 7 to become minus 5 root 7. Okay, so what happens next, guys, is they cancel. 25 minus 7 is 18, k equals 18. Question 9, now this is, we didn't do this last night, but I was getting there, okay? Now, I'm going to start off with question 2. So we're doing question 3 yesterday. Which is the more complicated side, the left hand side or the right hand side? Left hand side. Root 3 plus root 2 all over root 3 minus root 2. Now, this is very complicated because they both have root signs this time. Now, do you know what? I'll go over 9 part 1 first, okay? Because 9 part 1 is an easier version. So, it's 1 over root 2 plus 1, and I want to change it into that. Now, what I say is, I'm going to change it to look like this. Is everybody happy enough with that? The root comes second, the number comes first. Now, you multiply top and bottom by something called the conjugate. Anybody remember what the conjugate is? Whatever is in front of the root sign, minus version of it. So 1 minus root 2 and 1 minus root 2. Is that right? Now 1 times 1, 1. And then minus root 2. Then on the bottom, 1 minus root 2 plus root 2. And root 2 by root 2 minus 2. Now, what I would have done here the other day was I would have said 1 minus root 2. What happens to these two guys here? Then 1 minus 2 minus 1. It doesn't quite look like root 2 minus 1 does yet. What can I do to top and bottom? Cancel, yeah? And I get minus 1 times minus 1, which is 1 on the bottom, root 2 minus 1. Minus 1 times minus 1 is 1. Minus 1 times 1 minus 1 minus 1 times minus root 2 plus root 2. So the answer is root 2 minus 1. Guys, I'm just going to do it the same question slightly differently, if that's okay with you, okay? Now, we'll try another version of this, okay? Because I wasn't quite happy with that one either, because you shouldn't really get minus 1 on the bottom. So what happens if I try this out instead? Once again, just change the sign on one of them, okay? So example would be root 2 minus 1 on the bottom and root 2 minus 1 on top. Do you see what I'm always trying to do? I'm always trying to get the difference of 2 squares. Do you see that? It's always the difference of 2 squares on the bottom. Once I manage to make that, I'll be able to get rid of the denominator. So let's try this one out. 1 times that, root 2. 1 times minus 1, minus 1. Then on the bottom, root 2 times root 2, 2. Root 2 times minus 1, and then 1 times root 2, and then finally 1 times minus 1. Now this one worked out a bit easier, didn't it? 2 minus 1. So root 2 minus 1 all over 1, which is root 2 minus 1. You see, it didn't really make a difference what way I did it, did it? Once you make the difference of 2 squares. Let's try this one out then, okay? 9 part 2 looks quite difficult. It's actually not too bad. What I'd write down, if I were you, just write down difference of two squares beside that, so you know what to do. Difference of two squares on bottom. So look at this one here. Root 3 plus root 2. Root 3 minus root 2. Using the bottom one, what would be in the brackets here to make that the difference of two squares? Root 3 plus root 2. Does everybody know how Higgins got that? The difference of two squares is x plus y, x minus y. We currently have x minus y, therefore we must need x plus y. So root 3 plus root 2 for the second one. Whatever you do to the bottom, you must also do to the top. And look what happens when I multiply this out now. Root 3 times root 3 is 3. You could also write it slightly differently, couldn't you? What's root 3 times root 3? It's technically root 9, and root 9 is 3. Okay. What's root 3 times root 2? 3 times 2, anybody? So it's root 6. No number does it. It's a decimal of some sort. Root 2 times root 3 plus root 6. Root 2 times root 2. Root 4, which is 2. And on the bottom, guys, root 3 times root 3, 3. Root 3 times root 2 plus root 6. Root 2 times root 3. And then minus root 2 by plus root 2. Minus 2. Now look what happens. Cancels here, doesn't it? What's 3 minus 2 on the bottom? 1, isn't it? 1 on the bottom. No worries there. Now, 1 on the bottom. 3 plus 2. And then how many root 6's do I have? No, it doesn't work that way. Okay, I'll explain that in a second, okay? 2 root 6, okay? Let me show you, okay? Now, root 6 multiplied by root 6, if everybody's happy enough with this, 6 multiplied by 6 is 36, and the answer is 6, okay? That works for thirds. What also works for thirds is if I have root 18 divided by root 2, what's the answer for that? What's 18 divided by 2? 9. So root 9 works, and the answer would be 3. What doesn't work, however, is this. Okay? Root 3 plus root 4 does not equal root 7. Is that alright? So subtraction doesn't work, addition doesn't work. Do you understand? Only works for multiplication and division. If you want to check that out, just write down what root 3 is. If this does work, what should root 3 plus root 4 take away root 7? What should that be then? Should be 0. It's not. Means you can't do it. Is that right? Cool. So long story short, when you get root 5 plus, I don't know, another root 5, the answer is 2 of them. Not root 10, 2 root 5. Everybody happy with that? To the memory, guys, to the memory banks. Okay. And we got that question right. So does everybody understand how to do question 9 now? Complete the difference of two squares. Now, the last one, however, 9 part 3 is slightly different. What's different about 9 part 3? Anybody tell me? Instead of having one denominator, how many denominators do we have? We have 2 of them, yeah? So, this is the left hand side, the more complicated side. What can we do with both denominators? Do you remember we did it in the last exercise? Root 3 plus 1 and root 3 plus 1, and on the other one? And then on the bottom? Let's see what happens. Root 3 plus 1 plus root 3 minus 1. Both fractions are the same. In the same way that 3 halves plus 7 halves is the same thing as 3 plus 7 over 2. See the way I turned two fractions into 1 because I'm adding them, yeah? I'm going to do the same thing here. And then I'm going to multiply out the fractions. Root 3 by root 3. 3. Root 3 by minus 1. 1 by root 3. 1 by minus 1. Cancel, cancel. How much do we have on the bottom? 2 on the bottom. And what do we have on the top? 2 on the bottom, and then root 3 plus root 3. And then plus 1 minus 1 cancels. 2 root 3 divided by 2. The 2's cancel, giving you root 3. You could always use the calculator. Okay. On question 13, you're going to enter this into the calculator, okay? And when you get the calculator here, it's going to be root 5 over 60. Is that right? Root 5 over 60. Now, root 5 over 60, it's not exactly what we're... Root 5 over 60. Did I write this down properly? Yeah, it is, yeah. 1 over 3 of 5, yeah? Take away 1 over 2 times root 20. Ah, it's a rational. Q is rational number. That's okay. So it's actually the right answer, but here's how it's separated out. 1/60th multiplied by root 5. Is 1/60th root 5 the same thing as root 5 over 60? Multiply top by top, bottom by, it'd be a 1 on the bottom, and you get root 5 over 60. So therefore, what's the answer for K? K is what, guys? What's K? 1 over 60. Okay. Same thing with question 12, guys. Question 12, look, it's just a matter of being able to do that. There's no point. And then minus 7 minus root 5 squared. 28 root 5. The answer is K equals 28. Now, see this Q here, guys? See that Q? Q means that fractions are allowed as your answers. See the N here? That means whole numbers are only allowed for your answers. Does that make sense? Something that you have to learn off. Alright, guys. Anybody in class take a wild guess of what you're going to do for 14? I don't know, 14 part 2. No, you can't quite. Sorry? Finish off the difference of 2 squares. Do you remember we've been doing it all this time? Then what happens? 1 times 1 minus root 2 minus another root 2. Root 2 by root 2 minus 2 all over is plus 2. 1 times 1 1. 1 times minus root 2, and then 1 times that plus root 2. That's what I've been doing all the last, that's what we did since start class. Anytime you see a denominator on the bottom and your answer here doesn't have a denominator, does it? What you do is you get the bottom and you complete the difference of 2 squares and you multiply it by the same number top and bottom. So you complete the difference of 2 squares on the bottom and you multiply the same one on top. So if I was doing a question 14 part 1 instead of 14 part 2, all I do is I look at the bottom and I go, oh, if I put a minus here, it's the difference of 2 squares. And then if what I do on the bottom, I must do on top. And then it automatically gets rid of the fraction. You'll see now in a second I'm just about to get rid of the fraction. It's a minus 2, is it? So look at this, guys. 1 plus 2, 3. Minus root 2 minus another root 2. 2 root 2. 1 minus 2 minus 1. What can I do when I have a minus 1 on the bottom? Multiply top and bottom by. That corrects that into a 1 on the bottom. 1 second. Minus 1 by 3. Minus 1 by 2. Minus 2 root 2. So the answer is 2 root 2 minus 3. The one stuff said divising on the bottom. Fionn, you the question. Okay guys, look at this one. 17. Given that the area of the square has a length of side x, it's a square. That means all the sides are x. The area of the square equals 8. Write x in the form k root k, where k is element n. Okay. Okay. Now, what is keyword area? What is the area of a square? No, that's the perimeter. Knock that off, please. Length multiplied by width. Okay. It's length multiplied by width. Everybody see that? What is the length? What's the width? So it's x multiplied by x equals 8. X squared equals 8. I haven't got there yet. It says write x. See the keyword write x. So I'm going to just concentrate all my effort on x first. So square root both sides and you get x equals root 8. Look up root 8. It's 2 root 2. X equals 2 root 2. That's the same thing as k root k. See the way it's the same number that's outside the square root sign as it is inside it. That's why you're allowed to use the same letter twice. If I had an answer like 2 root 3, I'd have to write something like L root k, because the k and the L are two different numbers. Okay? Now, I was hoping for a question without k, but that didn't happen. Now, in the right angle triangle ABC, use the theorem of Pythagoras to find the value of k, where k is an element of n. Here we go, guys. What's Pythagoras' theorem? Can anybody tell me? The square of the longest side, which is the hypotenuse, equals the square of the other is equal to the square of the other two sides added together. So you square them and add them together. What's the longest side using your eyesight? Root k is the longest side. And then the other two sides, doesn't matter what order you put them in. Now here's what happens next. What's root k squared? K. And then 2 root 5 squared, 20. If you want the breakdown, 2 root 5 by 2 root 5. 2 times 2, root 5 by root 5. 4 times 5, 20. You can't be solely dependent on the calculator. You should know how to do them as well. What about the other one? 5 root 2 squared. You say 50? Come on, 50. Now, k equals 20 plus 50, which is 70. There you go. And we are done with this exercise, more or less. Okay.